This is June 2016, paper 1. This is question number 11. An underground train enters a station. The mass of the train and its passengers is 250,000 kilograms, and the total kinetic energy is 18 megajoules. State the relationship between kinetic energy, Ke, mass and velocity. Well, Ke equals a half times mass times velocity squared. That's the most important thing. Get that square in. Everybody forgets it. Calculate the velocity of the train as it enters the station. So we've been given this one and this one. So we're looking for rearranging for this. So if we rearrange for this, it would be 2 times Ke over the mass. Now to get rid of this, we square root this. And if we put everything in, we would get 12 meters per second. It's a calculate. Look how many marks you're getting for this. Even though you stated the relationship, it's still worth 3 marks because you have to rearrange, but not a normal rearranging because one of the terms is squared. It just happens to be the one that you want to work out. So getting rid of that square and knowing that the square root goes in there, then that is where the extra mark comes from. The driver applies the brakes to stop the train. State what happens to the kinetic energy of the train. So this is a classic energy transferred to surroundings. Very familiar with those who did a lot of studying for thermal physics. So if the energy is lost, where's it gone? It's always going to be transferred to its surroundings. You can have that through heat, sound, any other forms. The diagram shows a section through the station. The passengers who use the station are carried from platform level to street level in a lift. Explain why these passengers gain gravitational potential energy in the lift, even when they are below ground. So, 2 marks here. You could say that GPE equals mgh. Passengers have to move upwards to a higher point. So if they're moving upwards, h would be positive, so you are gaining gravitational potential energy. You could also say this is for distance from the center of the Earth. So not only is this showing the height that the person's moved, it doesn't matter if they're below level because it's showing that they're moving further from the center of the Earth, so they would be gaining kinetic and gravitational potential energy. The next one, the tunnels are designed so the trains go up a slope as they enter the station and go down a slope as they leave. The driver uses brakes to stop the train in the station and a motor to make the train move away. Explain how the sloping parts of the tunnel affect the amount of work that needs to be done on the train by the brakes and the motor. So, 4 marks available here. You could break it down into when entering the station. Now, the amount of work done in this same paper, I can't remember which question, but they asked you for an equation that linked force and distance. So work is the amount of force that it needs and the distance that it travels. So as it's coming in and it's going up, its kinetic energy is being transferred to gravitational potential energy, which is the question that they just asked you. So they're going up, so they gain gravitational potential energy. They're going up, so their kinetic energy must go into gravitational. So if some of the energy is going into gravitational, less energy is less work done by the brakes. So we're comparing those two situations. So if they're going up, kinetic energy is turning GPE. Less work is then done by the brakes, or less force needed to stop, or train stops more quickly. You're looking for that work equals force times distance. When leaving, so we're looking at the motor. So now we can transfer that energy back from GPE to KE. So less work is done by the motor to accelerate the car, or less force is needed. So this one, you had 2 scenarios, and you could look for those 2 marks for both those scenarios. So there's 1 mark, GPE, and this is our second mark. And then we reverse it for leaving the station. And that's question number 11.